Sorry for my server just shut down. So here is the equation. So you draw a simple 4-bar linkage, and you assign dimension for your first link. This time 40, and you copy this one. Okay, and then you assign another one. So here you enter equals 2 times quotation mark. You need to have quotation mark. So this is the length of D1. Then this becomes 80, and you can input any kind of equation driven by the known length. Like now you create D2, then this one you can make like D1 times 1, D2 times 2 plus together. Then you can have the driven link length, and also if here you change your 40 millimeters into 50, then this one will change into 100. So this is very convenient. Okay, so you make the R link, R1 link fixed. Then this is the 4-bar linkage, but this one is not full constraint, so we need to assign value of that. So this one make it 80. Then this is full constraint 4-bar linkage. Oh no, R1 still not fixed. So maybe like 110. Okay. So how to draw a 4-bar linkage with fixed joint? It's very easy. This is what you do. You draw these 4 lines and make 2 fixed link. So click first one, first join, fix it, make it horizontal fix. Then you assign a dimension. This will be like a crank rocker. And also, if you want to know what's the input output angle relationship, here you can assign the input angle, and then you measure the smart dimension for your output angle and make this dimension driven. Then this is your output angle, and you can change this 60 degree, maybe like 30 degree. Then this driven angle will change, so you can do the 4-bar linkage analysis on SolidWorks. Alright, and then third one, how to draw a slider crank mechanism with a slider and sliding path. So here we can delete your 4-bar linkage, and then first we can draw a sliding path. So horizontal one, and make this fixed. And here we draw this 2 link, and when you make this point on the line, it will coincidence at your first time, and make this link fixed, and assign some dimension for your link length, maybe 30. This one 80. Then this point only sliding on this horizontal line. This is a slider crank. And also, if you want, they have no offset for your sliding path, you just make this one coincident, make this point fixed. So this is a slider crank without offset. And for the same thing, you can measure your input output relationship. So for example, your input is angle is 30 degree, and you want to know what's your x coordinates for your slider. Then you got this value, and you change your input angle, then you can get x coordinates immediately. Don't have to do the equation. Okay, then force, how to draw inverted slider crank mechanism. So the inverted one is you have a slider on your coupler point. So for example, like this, and here is your joint, and this angle is fixed. So we make it 90 degree, and then you given some dimension for your link length, 50, and this one link length 100, and then you make these two fixed joint horizontal and fixed. Okay, maybe this is not long enough. Okay, then when you rotate this one, it's like an inverted slider crank. We can just make this one very long, so it looks weird. Okay, so when you rotate it, this is an inverted slider crank. Okay, and you can change your dimension, and also if you want to measure your input-output relationship, you just still do the smart dimension and change your input angle, then you'll get your output driven angle. Very easy. Okay, so the fifth one is how to rotate the link manually. We just always did. Sorry. So if you didn't select any of those symbols on here, you can just, if it's not fully constrained, you can just change the dimension. So you can just rotate it manually. So you did it this one, then you can rotate it. We always do it on your 2D sketch. Okay, and the last one is how to create an animated linkage motion. Then first you need to have part, then do the rest of the thing.